Today we shall be discussing about the salivary glands. The salivary glands, they can be based upon the size, that can be either major salivary glands or the minor salivary glands, or based on the type of secretory cells, that could be serous, mixed or mucinous. The example of serous is parotid salivary glands, the mucous is minor salivary glands, and mixed is submandibular salivary glands. The first are the major salivary glands. The major salivary glands, they are situated outside the oral cavity. They are three bilateral present. Paired glands are named as parotid gland, submandibular and sublingual gland. So they will have a long ductal system. Other are the minor salivary glands. The minor salivary glands, they are present in group beneath the oral epithelium, and they generally open by very small ductules. The example are the serous gland of the von Ebner, anterior lingual gland, lingual, buccal, labial, palatal, glossopalatine, and retromolar glands. Now let us discuss the structure of the salivary glands. The salivary glands consist of series of secretory end pieces that are acini, that are connected to oral cavity by a system of ducts. The secretory end piece consists of secretory cells that are arranged in spherical configuration round the central lumen. That has two types of cells. One are the serous cells and other are the mucous cells. The serous cells are specialized cells that synthesize and store proteinaceous material. They also synthesize polysaccharides. So the serous cells, they are pyramidal in shape with their base resting on the basal lamina and the apex toward the lumen. The nucleus, it is spherical and situated at the basal third of the cell. Accumulation of the secretory granules in the apical cytoplasm, it is the most prominent feature of this cell. The serous cells, they are seen in parotid and submandibular gland. The apical cytoplasm, it is filled with secretory granules. The basal cytoplasm contains the rough endoplasmic reticulum that converges toward the Golgi complex located apical or lateral to the nucleus. The lumen of the serous end piece has small extensions in form of intercellular canaliculi that are found between the adjacent serous cells. The plasma membrane will exhibit several specialization. The next are the mucous cells. They are the predominant secretory cells of the sublingual and most of the minor salivary glands. They also occur in the submandibular glands. The secretions, it consists of large amount of mucins. So these cells, they have a pyramidal structure as similar as serous cells, but have narrow band of rough endoplasmic reticulum and larger Golgi apparatus that are involved in the carbohydrate synthesis. The nucleus, the nucleus is flat and it is situated in the basal region. So the secretory component of mucocell acini, it will consist of round or tubular configuration with larger lumen, larger than the serous cells. The cells are pyramidal in shape with broader luminal surface. The nucleus is flattened and it is situated towards base. The apical cytoplasm, it is filled with the mucous secretory droplets. The mucus, droplets. They are larger and more irregular shape with more prominent Golgi apparatus, and also contains component like rough endoplasmic reticulum, mitochondria, lysosomes. Like serous cells, the mucous cells are joined by the intercellular junctions, but they lack intercellular canaliculi.
Demilunes of Giannuzzi. The mucous cells acini they may be capped at the blind end by the crescent of several serous cells that are known as demilunes of Giannuzzi. So since they are in shape of half moon, that is why they are termed as by the name demilune. So these are the serous cells at the distal end of mucous tubulo-alveolar secretory unit of the certain salivary glands. So when the gland has this demilunar structure, it produces both the serous and mucous secretion, and that is why it is known as the mixed one. So their secretion reach the lumen of the end piece through intercellular canaliculi between mucous cell at the end of the tubule. What are myoepithelial cells? These are also known as basket cells. So these are the contractile epithelial cells. So these are also end piece cells belonging to another family having no secretory function. They are also known as basket cells as their shape appears like basket containing the secretory cells. So these are found abundant in the mammary glands. So myoepithelial cells, as the name suggests, they have muscle-like contractile function, and these helps the secretory acinus to expel their products. So these cells will have a octopus-like structure situated in the intercalary duct. So they are located between the basal lamina and secretory or duct cells and are joined by desmosomes. So they are stellate or spider-like with a flattened nucleus surrounded by small amount of cytoplasm and a long branching process that embrace the secretory duct cells. What are the function of these cells? It causes expulsion of saliva from the secretory end piece to the ductal system. They causes contraction of myoepithelial cells of intercalary duct that may shorten or widen the duct, and hence it helps in maintaining their potency. It helps to maintain the cell polarity and structure integrity of the secretory end piece. They also produce certain proteins that have tumor suppressor activity, such as like protein inhibitors. Like example is tissue inhibitor of metalloproteinase and anti-angiogenesis factor. Now, what are the classes of ducts? There are three classes: intercalated, striated, and terminal. The terminal secretory duct it will it will open into small duct known as intercalary duct. So these duct they join to form a larger striated duct, which finally empty into a larger excretory duct. So the ductal system of salivary glands, the main excretory duct opens into oral cavity. So these excretory duct are located into the interlobular connective tissue. The stratiduct they are the main intralobular ductal components. The intercalated ducts they connect the secretory end piece with the striated duct. The intercellular canali they are extension of lumen of end piece between adjacent secretory cells that serve to increase the surface area available for secretion. The intercalary duct these are the small ducts into which the secretory end piece empty. They are lined by layer of low cuboidal cells and epithelial bodies and their processes. Their lumen is larger than the secretory end piece. They have a centrally placed nucleus lit with the little cytoplasm, rough endoplasmal reticulum, and Golgi apparatus. There are few microvilli that are projecting into lumen. They are joined to adjacent cells by apical junctional complexes and scattered desmosomes and gap junctions. Remember, the longer intercalary duct is seen in parotid gland, the shorter is seen in submandibular gland, and it is poorly developed in sublingual gland. What are the function of these ducts? They act as a channel for salivary flow. They contribute to the salivary secretions like lysosomes and lactoferrin. Ferretti duct. These are the larger duct into which the intercalary duct empty. They are the main ductal component in the intralobular portion of the gland. They are lined by tall columnar cells. They have a centrally placed nucleus with the pale cytoplasm. The basal striations are perpendicular to the base of cells. The mitochondria, they are lying in the cytoplasmic partition produced by infolding of basal plasma membrane. So their function is to modify the salivary secretion, changes the salivary secretion from isotonic to hypotonic, along with sodium reabsorption and potassium excretion.
The terminal secretory duct, they are the duct through which the salivary fluid from the gland it is secreted into the oral cavity. So as the duct run from the exterior to the secretory duct, its size and cell structure changes. The size increases from starting to the end, and the cell layer changes from pseudo-stratified columnar to true stratified squamous epithelial cells. Their function is to modify the finer saliva by altering its electrolyte concentration. The nerve supply, it follows the course of vessels. It has two patterns, one is intraparietal and other is extraparietal. The next is the connective tissue. It has a capsule that demarcates the gland from the adjacent structure. It has septa that divides the glands into lobes and lobules. There are nerves and blood vessels and excretory duct along with the fibroblasts, macrophages, dendritic cells, mast cells, plasma cells, and the adipose tissue. The collagen fibers and elastic fibers along with the glycoprotein and proteoglycan of the ground substance, it will form the extracellular matrix of the connective tissue. The parotid gland histology, here the cells are mostly serous types. There is presence of numerous intercalary duct, long and branch striated duct, all also seen that stains pink with eosin dye and appears as pink necklace in the stained section. The submandibular gland, it has a mixed acini, about 80% of serous cells and 20% of mucous cells. The intercalary duct here are less and fewer, and the striated duct they are longer and more developed as compared to the parotid glands. The demulons of serous glands are present over the mucous terminal portion. The sublingual gland, it contains mucous cells. With the mucous cells they are more, the intercalary duct they are short and are difficult to recognize. Intralobular duct are fewer in number than parotid and submandibular gland. The minor salivary glands, they are mostly mucous. Occasionally demulons may be present. They consist of aggregates of secretory endpiece and ducts that are organized into lobules-like structures in the submucosa or between the muscle fibers of the tongue. Now what are the stains we use? For the serous cell we used toluidine blue or specific cytochemical technique is used. For the mucous cell, some special stain like PAS or Alsatian blue they are used. What are the age changes in the salivary glands? The function of the salivary glands reduces slowly with the age. That may be due to the histological changes in the gland. There may be fibrosis, fatty changes, alteration in the mitochondrial structure, or accumulation of the
lymphocytes.